on time. We want to make up for some time lost. So if your friends are outside, you can just quickly text them to come back, but we will get started. I want to start by saying thank you to Sparkle Adventure, our co-powered partner, and also CL Educate, that's Career Launcher, our gold partner. Thank you for supporting us. Okay, is everybody awake? Is everybody asleep? Ah. All right, looks like it's yes for both. But the next one, I am looking forward to learning this. This is a workshop, it's an interactive workshop, and it's called RoboRangers, Build, Code, Conquer. And it's led by the team at Orangewood Labs. I'm secretly hoping it's no-code code so that all of us who don't know also can learn something about building robotics. So please welcome Satish Avi, COO, Jia Nagpal, Computer Vision Engineer, Tushar Gaurav, Software Engineer. Yes, please start.
Hi everyone, it's after lunch, huh? Very bad for me. Great, can we have the slides? Perfect. How many of you guys are robotics engineers here? I am audible, right? Perfect. How many of you guys are interested in robotics, or they want to explore something in robotics, or they want to use robots? Perfect. Okay, quite good. The questions which I want to ask you right now is, why does it take months and lakhs of rupees to create a single robotic application? It's very expensive. Robots is fancy, it's good, it's interesting, it can solve multiple problem statements, but it's not cost effective, it's expensive. You need a lot of skills, you need a lot of technical understanding, uh, cross, you need a software understanding, you need a mechanical engineering understanding to build a robotic application. Since you are interested in robots, why do you think that most of the projects do not see the light? They are either dead in the prototyping stage, or they are not able to get to the industry level. There are a lot of other questions, like, if one person can just have an idea, and with the current tech what we have, if somebody is just thinking, and then you can just create an industry grade program, not a prototype level, or not a just one simple program. No, I'm talking about an industry grade program. Just you are thinking about the problem statement, and you are able to execute the entire problem statement in the industry. So these are set of questions which I have, which I believe most of us are thinking in their mind, that if the AI is so advanced now, if we are thinking something, we are able to create some program, we are able to create some text, we are able to generate some output out of our thought process using any of the LLM models. Why can't hardware? Why can't we create an industry level problem statement by leveraging the power of AI, and by leveraging the power of the latest tech what we have, by integrating various hardware, and then create an industry grade problem statements? You don't have to rely on any of the 5 years, 10 years experienced person to understand, can I do this or not? Are these questions which you are always having, or these are the bottlenecks for you guys to get into the robotics side? Can I have a yes or no or maybe? Perfect. So you have a robot over here. I'll get to the slides in a couple of seconds. You have a robot over here. If I'll just say that you have access to the robot, give me a pick and place application, or give me an industry grade applications, you will feel that pain, that if I want to create one program, I should know how to operate this robot, I should know how to create programs on this, I should have to know the entire manual and all those things. So this basically is what we are trying to solve in Orangewood Labs. So I'll give you a very high level understanding of what we are doing and what exactly is the problem statement we are solving, because robots, it's hardware. 5 years down the line, 10 years down the line, hardware will be available in the market. It will become cost effective. But skills, are you getting to that skills or not? Are you at that particular speed or not, right? So this is what we are doing. We are not just approaching the hardware story. We are actually approaching from both the sides. Both software, hardware come together on a platform so that the skills are becoming easily available, or the skills are becoming de-skilled. The level of skills are becoming lower. So that is what, right? So if let's say these are the applications, robotic cell development, you must have seen a lot of videos across industry where you are seeing it's a very complex application. There are a lot of machineries and everything is talking to each other. And those machines has to work 24/7, right? This is how we can solve the problem. This is how we are planning, or we are trying to hard to solve the problem with the RoboGPT platform. Okay. So what we are doing, a little bit about us. We are a YC-backed company. We started back in 2018. We were building, or we are trying hard to build our own robots. This is the 6th version of our robot, what we are building. There is a new version which will be launched maybe next month for basic applications, and then all the R&D testings and calibrations, everything will be going on. So next year we are expecting it will hit the market for all the applications. So this is the 6.8 version of our robot, which is continuously doing all the quality inspection, powder coating applications, bin picking applications, which is easy to operate, which is a little bit economical compared to other robots in the market. It is collaborative, meaning there are multiple other features which will help this robot comfortable to work with humans. It is teleoperable, which means you can operate this robot from US also. A simple application or a simple setup which is there in US, you can control that particular robot here from India. So these are the basic applications. I think there are a couple of images. All of these are industry grade applications. I am facing problem in this, but yeah. So these are the industry domains where we are, closing all the industry grade applications from the solutioning side. I mean the industrial applications with the MSMEs or SMEs or enterprises. So automotive industry, we have machine tending, we have pick and place, we have dispensing, we have pelletization, we have surface coating. Every part in the industry, in the car manufacturing or automotive manufacturing, every surface is either spray painted or surface coated. There is an operator who is sitting inside the booth, and then he manually does just this particular action. We are trying to automate that particular activity, in the industry. Then we have lab automation. Imagine you are going inside the lab, and one fine day, Sunday, you have to extend just to go and switch on the machine, just to go there and do some simple applications. You don't want to go there, right? Just for switching on the apparatus or something like that. You can have a CMR kind of setup. So this robot on top of AMR can go inside and then just do that particular activity. The major problem here is variability, flexibility. That variability, flexibility comes with the AI. That is what we are trying to solve. Packaging industry, every secondary packaging applications can be automated using robotic applications. Right now, it's a little bit expensive, but with the power of AI, with the power of innovative solutioning, now these products or solutions are becoming cost effective, right? Plastic industry, again, machine tending, assembly and handling, similar kind of thing. Solar industry, we are now able to get ROI from 5 years to 2.5, 3 odd years for the industry. So every solar panel chip can be inspected, can be picked and placed 24/7 without taking any breaks, without taking any complex programming. So that is what the power of RoboGPT platform is, and the robots. Food and beverages, electronics, all everywhere the application is same. 70% of the task in the industry is basically pick and place. You're picking something, you're placing somewhere. You're picking something, switching on something, placing somewhere. You're picking something, switching it on, understanding what is the scenario, dynamically taking that particular decision. This is what is happening in the industry, right? So this is what is the scope of automation across globe. Now, what is RoboGPT? I've already given you a very high-level understanding of what RoboGPT is. Imagine I'm a, undergrad pass-out student. Just cleared my undergraduation. And day one, I'm going to a factory where I have to uh, understand or program a robot or operate some machine. Day one, what will happen? They will give me some booklets or some manuals to read. They will also give me couple of engineers who can guide me to understand how to operate that, and they will teach me one simple things: how to hold a tool, how to operate, how to switch on a machine, what next, what next. If something happens, slowly they will tell me that, this is your next step. If this happens, this is your next step. So there is a clear-cut instructions which is being followed on every machine, and under any emergency situations, how to handle that emergency, keeping in mind what exactly is happening in the scenario. Basic common sense, right? This is how you run our industry based on the knowledge. That's the experience. What we are trying to do is everything we are bringing everything on the platform. So imagine in the RoboGPT platform, you have automotive industry ka skill sets, you have FMCG industry ka skill sets, where you are saying if you want to deploy a palletization application, these are the 5 critical things which needs to be done, taken care of. And those 5 applications or concepts needs to be taken care in this fashion only. So it's a user manual kind of thing, right? So these skill set we are building on top of a RoboGPT platform, and then based on your application, if let's say I am on day one going in industry, I'll say this is a machine tending CNC machine where I need to pick up a tool and then do this. Little bit of vision inspection is required. So I'll just go on top of inside a platform. I'll say, hey robot, this is my tool which I want to pick and place, and the placement has to be in this particular fashion, not like this. It has to be like this only, and I can hold like this. I cannot hold like this. So these are small things which I will teach. These are basic skills which I'll teach the robot specific to my application, and then rest everything I can actually pick up from backend skills. For example, I'll say I am handling a Jyoti CNC machine. There is one CNC machine based out of machine manufacturer based out of Rajkot. So I'll say I am handling a Jyoti CNC machine of this make. This is the model number. I want to do a pick and place application. Tell me how to do. This is my object. The entire programming, the robot, the RoboGPT will be able to solve. Now the parameters over here, it is robot agnostic. So you will pick up your robot, you will pick up your gripper, you will pick up your problem statement, what and how you want to do, and then you will just execute. Obviously, there will be some checks in between, which needs to be taken care. For example, you will see simulator mein everything is happening correct or not, whether this is what you require or not, and then in 1 or 2 iterations, everything will be happening. So this is a small video. The video is playing. I think it got converted to text. So what is happening here is, this is a robot which have couple of cameras to understand what is the environment about. So I'll just put a prompt, give a prompt, hey robot, pick up blue object in front of you. So what it will do is, it will scan. If it sees that the object is not there, what it will do, it will scan the entire area, give the understanding, hey, I do not see a blue, but I see a black box over there. So it will give you an output. I see a black box. Do you mean that this is what you want to pick up? That interaction will happen. So it's a continuous feedback kind of thing. And then it will go and then pick up that particular object and then place it. India is full of unstandardized processes on the factory floor. This is the problem statement which we thought or which we are experimenting with a lot of MSMEs in India so that they are able to take care of those non-standardization with RoboGPT platform. So we use a lot of robot controls. So you can talk to a robot, you can type in a user interface with the robot, and you can interact with the robots also. The core capabilities of the platform, and this is how you interact with the platform, it's able to build its own program. It will not execute until unless you are 100% sure that this is correct or not. So all the safety features are also inbuilt. Efficient task handling, seamless integration. It has PLC, it has multiple robots, it has NVIDIA, it has a lot of computer vision cameras, industry-grade cameras or basic cameras. You can integrate with your camera, you can your mobile phone, you can integrate with Slack channel also, if you can integrate with WhatsApp also. It's like a workflow with hardware inside that workflow, right? So core capabilities, as I said, natural language processing. It doesn't matter what language you speak. It doesn't matter whether you are speaking a correct grammar or not. It doesn't matter whether you are speaking in Telugu, Tamil, French, anything, doesn't matter. Path generation, if let's say I'll say you have to pick up from here to there, it will be automatically able to execute the entire activity. Imagine, it's a very simple problem statement which my US investors were, kind of got excited seeing that. We depicted the entire barista style making process using our robots. So I just gave a prompt, hey robot, make a barista style coffee for me. The entire activity, it was pre-trained, pre-programmed with a lot of variables under control. So it was able to make the entire coffee. One of the investor demo what we did was we just simply said that just open your purse, drop a couple of items, tell me what exactly you want me to pick. So there was some, I think lipstick was there. So she said, pick up the lipstick. It identified, picked up the entire lipstick and then handed it over on the bin. So that level of flexibility, that level of freedom you will have, and you don't need a robotics engineer now to run a robot, to troubleshoot a robot also. Yeah, next. These are the key features which I have already covered. These are the industrial applications. So here I would like to take one particular, highlight one particular point. Imagine I have done 50 odd installations in automotive industry. If you are part of the automotive industry and if you want to program a new if you want to create a new program for the automotive application, generally what happens, you as a MSME leader or an enterprise leader, what you will do, you will float the form to all the vendors who are solving the problem statement. Then you will rely completely on their expertise, that this is my scope, please get me done this. If he or she defaults, you have to go to the next vendor, until unless that problem statement is solved. So you are dependent on somebody, right? You have to have in-house skill sets of resources. So that's why the entire cost is high for owning a robot in the industry or owning a robot in a university also. We have seen multiple universities having a robot sitting idle. Why? Skills. They don't know the problem statements from industry, or they don't have a proper roadmap of what type of applications can be executed using a robotic arm, right? Specific problem statements, or I would say bridge the gap between industry and academics. The direction where 5 problem statements will end up getting the entire industrial expertise for that particular candidate. So this platform actually enables them that, if I have a new application for automotive industry, I'll just go inside the platform, get into the automotive industry skill set. There will be 5 predefined industries, applications. You will select one. It will give you a predefined problem statement. You have to just, update all the parameters. The robot will be able to execute all those applications. Couple of them are templatized, couple of them are standardized. So if it's a fixed machine, it has to be templatized. If it's a uh, random problem, some problem statement, you can build your own skills also. So any sort of industry grade or any sort of R&D level problem statement, you'll be able to solve using these uh, skills industry-wide. Well, when we say RoboGPT, it's a very fancy word. It's robot plus GPT and all those things, right? How exactly it matters? Why it is important that students or researchers or whoever is not skilled should get onto this platform and explore and do the R&D. When you have a robot, first of all, there's availability of robot is the biggest challenge right now, right? Either you do a 3D printed robot or you connect with some industries or you do some internships just to get access to the robot. That is how you start operating a robot or learning robot. The best part here is any 3D printed robot can be onboarded to the platform, provided couple of parameters are fulfilled. Second one, if you have any robot can be integrated with this, any industrial make or anything. We will take some time to onboard one by one, but it is flexible because it's a software to software integration between the robots. So once you have integrated all those things, we will, on this platform, we will define multiple problem statements. Multiple problem statements will be shown to you. This is how other people are doing. This is how industries are solving the problem statements, various case studies and everything. That's how you start learning. You have a ready-made example available with you on how you are solving the problem. So imagine I give you a machine tending application with variable speed, with variable collision relaxing parameters, with variable pick and point application, with multiple computer vision integrations. What you will do is, you will simply say, machine tending application, vision skill I want to load. So you'll simply say, I want to use vision skill set, please load. So you'll go to automotive section. Inside that, there will be, let's say, Cognex camera or bomber camera ka skill set, integration skill set. You'll just integrate that and start using it. Matrix, I think you must have seen. You are uploading one skill set, wo aa jata hai, then you start flying aircraft or helicopter or something like that. Something similar to that. That you are going there, you are picking up the skill and then you're executing it. Nothing more than that. Industry professionals, you can get in touch with industrial professionals who are contributing on the platform. So it's kind of a platform where in one side there are academic, people from academics, people who are doing R&D, people who have limited skills specific to their problem statements, but they want to collaborate for the other hardware skill or software skill. People who do not know ROS 1 but want to learn ROS 2 on the robot, something like that. So this is how we are kind of creating a platform where the gap between the academics and the industries, the basic application and the skilled application, this is how you can actually plan to solve. Another thing which we have seen that a lot of students are using. Imagine you just want to create a problem statement. You want to solve one problem statement. You will just say that, this is what I want to do. Give me the solution. So RoboGPT will give you one particular, output. So it's an output from the RoboGPT, like how a 5-year experience or 10 years experience person will solve that particular problem with the same scope. Now you have a ready-made solution available in the customized ready-made solution available for you, for your problem statement. You have an example, solved example, reference. Now start learning that. So that will become fast track now, in the fast track mode, right? That's how a lot of people are using it. These are the skill sets what we have right now. We were able to run the entire drilling machine using our robots. So the only prompt which we have to give is, please run drilling application. I have 5 objects, do the drilling application one by one. It was able to do entire thing on its own. In that entire activity, if the object is missing, it will stop. If the object is picked up in a wrong direction, it will stop. If the object is not completely picked up, right, some angle where the problem is happening or something like that, it will stop. So that's how we are kind of adding all the skills one by one. So we have machine tending application, we have pick and place application, we have visual inspection application also. Yeah, I'll go to next. These are the benefits which we have, understood that, these will be expected. 85% learning curve reduction, setup time saved. When you want to, eh, when you want to test, you don't have to do the entire application again and again. You learn once, and then just try to speed up your entire R&D process. That's how you speed up your entire productivity. So productivity, you will be also be able to increase. Because it's a platform, it comes with all the platform capabilities. So you'll be able to manage your skills, you'll be able to interact with each other in the community. You will be able to understand how other people are doing. You will be able to see whether your applications, your examples, your mini projects, your life